So how do we use the direction of acceleration for objects in circular motion to draw the direction of a net force vector, and then also consider how we can draw the free body diagram for an object that's undergoing uniform circular motion? So the connection that we want to remember here is that acceleration and net force always point in the same direction. So your centripetal acceleration and your centripetal force always point in the same direction. And that direction is toward the center of the circular path. So let's take, for example, here you have a car that's driving over the top of a hill, and we can think of the center of that circular path being below where the car is. So here's what our circle would look like. Here's where it's located. So with that being the case, we have two forces that are acting on the car. We have the downward gravitational force, and we have the upward normal force from the road. And when we're drawing our force diagrams, we want to consider which of those forces is larger, or are they balanced? But because our acceleration would be toward the center of the circle, that means our net force is toward the center of the circle. So that points downward. Our acceleration is downward. And with the acceleration pointing downward, that means our net force is downward. So our larger force is pointing downward, which means that the gravitational force is larger than the normal force. Let's flip this around for another example. If you have a car going through a little dip in the road, and the circle we can kind of picture this way, we have the center of the circle positioned above the car, if you can kind of imagine it that way. So with the center of the circle being positioned above the car, the normal force points up, the gravitational force points down, just like before, but they're balanced differently. The gravitational force now is smaller than the normal force, because with the acceleration pointing upward toward the center of the circle, the normal force, the upward force, is larger than the downward force.